Thanks to NordVPN for sponsoring today's video. Back in April, NASA announced that they would cease operations of the infrared telescope known as SOFIA. If you have never heard of this telescope, you're in for a surprise. SOFIA is a fascinating example of NASA trying something quite different, and although it did not prove to be as effective as they might have wanted, the incredible engineering that went into it and the things it discovered make this telescope an important part of space history. But what is SOFIA? Well, it's not a ground-based telescope, neither is it a satellite-based one. SOFIA is a telescope that sticks out the side of an aeroplane. I'm Alex McColgan and you're watching Astrum. Today, as we near the end of SOFIA's operation, it seemed appropriate to look back on the history of this quirky telescope and learn about the design choices that went into it and what discoveries it made, and ultimately ask, was it worth it? I don't know about you, but when I first saw SOFIA, or the Stratospheric Observatory for Infrared Astronomy, my mind was immediately buzzing with questions. Most pressingly, why an aeroplane? Why not a satellite like Hubble, or James Webb, or maybe something ground-based? You might guess that the modified Boeing 747 that houses the telescope is possibly cheaper than launching a satellite into orbit, and you'd be partially right, but not as right as you might think. SOFIA was expensive to build and expensive to operate. To make a few comparisons, while it cost NASA $1.5 billion to build and launch the Hubble telescope, SOFIA still cost $1 billion in an 80-20 collaboration with German scientists. Not that far off. And the $85 million a year required to keep it going isn't that much less than Hubble's ongoing maintenance costs. In fact, the high cost of SOFIA was cited by NASA as the main reason for discontinuing it. You might wonder whether it's more fuel efficient than a rocket. Rockets certainly are fuel guzzlers. The SpaceX rocket Falcon 9 uses over 75,000 gallons of propellant, a mixture of liquid oxygen and kerosene. This fuel top-up for the reusable rockets costs $200,000 to $300,000, but SOFIA's Boeing 747 is actually comparable. Its tank fits around 60,000 gallons of a different type of kerosene, which also costs around $200,000 to fill up. And given the fact that it flies 3 times a week for 10 hours at a time, burning through about half a tank in one run, all in all, that's a lot of expensive fuel used. But it does have some advantages. The main benefit of space satellites is that they get above the Earth's atmosphere. Air molecules refract light, which means that if you can get above the atmosphere, you can get much clearer, crisper images. SOFIA is able to fly above 80 to 90% of the atmosphere, so it shares this advantage with a space satellite. But unlike a satellite orbiting the planet, at the end of a flight, SOFIA can come down again. This makes it much easier to maintain, and also to swap out its scientific equipment, giving SOFIA much greater flexibility in the sorts of things it can detect. This has proved invaluable in SOFIA's 8 years of life, as we'll see later. Still, I don't think this is the true reason SOFIA is an aeroplane-based satellite. To understand the real reason, it's important to know a little bit about the history of flying satellites. For SOFIA was not the first. Flying observatories actually date back to 1957 with the balloon Stratoscope 1. The idea was simple. Put a telescope on a balloon, send it 25 kilometers into the air, and have it take photographs of the sun. However, plane-based telescopes wouldn't come along until the solar eclipse of 1965. Phenomena like solar eclipses are very location-based. Depending on where you are in the world, you will get a better or worse view of a solar eclipse. As the moon travels between the Earth and the sun, its shadow travels across the continents, meaning some get to see the full eclipse, while others only see a partial eclipse, or none at all. So NASA decided to put a telescope on a plane to chase the solar eclipse across the globe, thus giving it the best view of this phenomenon. This was something that only a telescope on an aeroplane could do. Neither a fixed-in-place ground-based telescope nor a locked-in orbit space telescope could be exactly where it needed to be. The first telescope was put on a Convair 990 and was named Galileo, after the famous astronomer. Galileo's eclipse-chasing mission was a success, and did so well that NASA asked itself the age-old question, what if we do a bigger one? This led to the Kuiper Airborne Observatory in 1974, and then SOFIA being proposed as an even larger iteration again in 1996. SOFIA is a technological marvel. Getting a telescope to work on a moving aircraft is about as difficult as spinning a plate on a stick while standing on the roof of a moving car. Don't try this, by the way. SOFIA would need to take images of objects millions to billions of light years away. To do this, it would need to remain perfectly still, even as the plane around it rocks with the wobble of turbulence, the vibrations of its engines, and the rush of wind ripping into the telescope's open cabin. If the telescope vibrated even slightly from any of this, it would be impossible to track the stars and planets it was trying to see. It would repeatedly be supercooled by the low temperatures of high altitude, then warmed again at ground level, potentially leading to cracks and damage to the 8 nanometer precise mirror. An incredible task NASA and German scientists had set for themselves. They solved these problems ingeniously. SOFIA's telescope is set on a series of gyroscopes, magnetic torque motors, and high-speed cameras that allow it to remain perfectly still as the plane around it moves. The door that opens on the side of the airplane comes equipped with an intricately sculpted ramp on one side, tested in wind tunnels to reduce the 850 km/h winds the Boeing flies at to just 80 km/h. And the mirror itself is built using a ceramic glass composite called Zero-Dur that has almost no expansion or contraction under temperature changes. Its equipment is unique in almost all the world. SOFIA is primarily an infrared telescope, but thanks to some additions that were made to its Hawk equipment early on, SOFIA is one of the few telescopes capable of seeing the polarization of dust clouds. This gives SOFIA the incredible ability to see magnetic fields across galaxies. However, with its greater size and sophistication than its smaller forerunner Galileo, SOFIA's costs grew too great for its scientific contributions. SOFIA began its 5-year mission in 2014 and was then given a further 3-year extension. But while in its first 6 years the Hubble telescope was cited in more than 900 scientific papers, SOFIA featured in only 178. This led the National Academics Decadal Survey on Astronomy and Astrophysics in 2020 to conclude that SOFIA did not contribute enough scientific discoveries to justify its high running costs. NASA took their recommendations on board and concluded there was no room for SOFIA in the future of astronomy, seeing as there are likely bigger and more exciting infrared telescopes on the horizon that could better use the funding. So, was SOFIA a quirky idea that went too far? Some in the infrared telescope community would say no. Its productivity was ramping up towards the end of its life, even as NASA decided to cancel it. But ultimately, the value of its existence can only be weighed by its discoveries. Let's examine a few of the biggest so you can decide for yourself. Being an infrared telescope, SOFIA is able to see through thick bands of dust that visible light telescopes would struggle to penetrate. As such, it has been able to capture moments like this one in the Orion Nebula. Here, a young star creates a bubble of space around it by blowing the dust away with its stellar winds, in a process known as feedback. It was previously believed that only supernova could do this, so discovering that regular stars did the same has been a key discovery in understanding the formation of stars in the early universe. The stellar winds prevent new stars from forming too close to the current one, while also compressing the dust further out, increasing the chances of stars being created further away. And what about this planetary nebula, NGC 7027? By analyzing its light signature, scientists were able to discover helium hydride in space for the first time. This molecule had long been thought to act as a key building block for more complex chemistry back when the universe was only 100,000 years old. But up until SOFIA spotted it here, scientists had had no proof it actually could be found in space, having only created it in lab conditions. One of many examples of theory outpacing observation. SOFIA's ability to see in infrared gives it insights into the temperature of the universe. For instance, by noticing that the infrared brightness of debris in this double star system was 10% brighter than it had been a decade ago, scientists were able to deduce that two large exoplanets had likely violently collided into each other in the system, heating up the matter and dust around them. This cataclysmic collision would otherwise have been very difficult to detect. But my personal favorites of some of the most mesmerizing images are these. These strange lines that you can see weaving through the images of stars here are magnetic fields that channel mass in ways scientists had only dimly perceived up until SOFIA. These fields can allow mass to escape from galaxies, can keep it away from black holes like the one in the center of our Milky Way, keeping it peaceful and quiet, or can funnel mass towards black holes, ensuring they are constantly consuming mass. If you want to know why the universe works the way it does, understanding the role of magnetic attraction is as vital as understanding gravity, and that's something SOFIA gives us like no other telescope. From nebula to planets, from the formation of stars to the fundamental building blocks of the universe, SOFIA has peeled back the curtain to reveal fascinating secrets, and has done so in a way that is truly unique. Men and women have ridden along with it, performing science in real time as it swept its gaze out across the universe. Perhaps it was a relic of a bygone time, and planes are not the true future of space exploration. But without trying things out and innovating, we would never really know. So, what do you think? Was it good that we had SOFIA, even if only to say that it didn't achieve as much as we hoped? Or would the money have been better spent elsewhere? What is the price we can put on experience and knowledge? Either way, for better or worse, for nearly a decade, NASA and German scientists really did try to stick a telescope out the side of an aeroplane. And that is a fact that has expanded my understanding of what is possible. Want me to take an episode diving deeper into the discoveries of SOFIA? Let me know by liking this video or in the comments below. Now, SOFIA can see what most other instruments can't, thanks to the upgrade it received. Did you know there's lots of stuff going on behind the scenes on your internet device that you may not be able to see? One of the creepiest, I think, is malware ads. Some malicious ads disguise themselves as simple advertisements, and once you click and load them, your computer sends your device info to a bad party like your IP address, browser, OS, and more. Some don't even need you to click. With that info, the bad party can send back automatically picked malware suited to your device. The solution? Keeping your system up to date helps, but mostly you'll need a way to block these ads, and NordVPN's threat protection feature does exactly that, plus a host more. Get an exclusive NordVPN deal, including Nord's threat protection, at nordvpn.com/Astrum to get a 2-year plan plus 4 months for free. I highly recommend checking it out. Thanks for watching. If you enjoyed this video, feel free to check out my other telescope videos here. Thanks to my patrons and members for supporting the channel too. If you find value in these videos and want to help the channel make more, check the links in the description below. All the best, and see you next time.